Welcome back, everyone. Today, we're going to be taking a deep dive into the world of AI and software engineering with a paper called Training Software Engineering Agents and Verifiers with SWE-Gym. It's a mouthful, but trust me, it's really cool stuff.
It is. We're talking about AI that can solve coding problems, address bugs, just like human developers would when they're working on, GitHub issues. And the challenge that this paper is trying to tackle is how do we train those AI agents effectively?
Yeah, training AI to code well,
Hmm.
like proficiently, is a lot harder than training a chatbot, for
Hmm.
example. And one of the main reasons is there really haven't been good environments to train them in. But this research kind of changes that.
It does. This paper introduces what they call SWE-Gym, and it's this really unique and realistic training ground for AI. It's not just theoretical. They use over 2,400 real coding tasks from 11 popular open source projects.
Wow. That's a lot of real-world data. And what's even more impressive is the effort they put into making this SWE Gym thing as realistic as possible. The authors actually spent over 200 hours and 10,000 CPU hours configuring environments for each task.
Wow, that's dedication.
Yeah.
And all that work really ensures that SW-Gym mirrors what real-world software development is actually like. And it pays off because the AI's performance after training with SWE-Gym improved significantly. One model went from solving like 3% of tasks to over 15%.
That's a pretty substantial improvement. So what makes this SWE Gym so effective? What's going on there?
Well, there are a few things that make it really special. First is it uses actual GitHub issues as the assignments for the AI. So it's like giving them problems that human developers face every day.
Mm.
And the second thing is they pre-install all the necessary code and dependencies for each task, just like you would have on your own computer as a developer.
Oh, interesting. So the AI isn't given any shortcuts. It has to work with the same constraints as a human would.
Yeah. And finally, SW-Gym has unit tests. So it rigorously checks that the AI solutions actually work. They actually have to, meet the same standards as a human developer.
So it really is like a coding boot camp for AI. They have to show their work and pass the tests. So how does this paper actually approach the training of these AI agents?
Well, they explored two main approaches. The first one is called general purpose prompting, where you kind of let the AI figure things out on its own a little bit more independently. And the second approach is what they call a specialized workflow, where you guide the AI through kind of predefined steps.
It's interesting how those two approaches um, kind of mirror how humans learn to code. Right. Some people prefer to just dive in and figure things out on their own,
Yeah.
and others do better with more structured guidance.
Yeah, it's that whole learning styles debate.
So let's talk about that first approach, the general purpose prompting. How do they go about doing that?
Well, for general purpose prompting, they used an AI agent framework called Open Hands. And basically what this does is it gives the AI access to a bash terminal and a file editor, so it can actually interact with code and execute commands, just like a human developer would.
Wow, so they're really simulating that whole developer environment and workflow. What were the outcomes of this approach? How did the AI perform?
What they did is they collected what are called trajectories, and that's basically a record of the AI's actions and outcomes as it's trying to solve these coding tasks. And they found that even with a limited number of these training trajectories, the AI's performance on something called SWE-Bench, which is this benchmark for evaluating AI that does software engineering, it improved significantly.
That's promising. So even a small amount of focused training data can make a big difference.
Yeah, it really seems like it can. And they also found that this approach led to a reduction in what they called stuck in a loop behavior, where the AI just keeps doing the same thing over and over and isn't really making progress.
Yeah, that makes sense. So the AI was getting more efficient and strategic with its approach.
Yeah, it was. And better at like understanding the problem and avoiding dead ends, which is pretty cool.
Definitely. Now, what about that second approach, the specialized workflow? How did that one play out?
For the specialized workflow, they use something called the Moteless Tools Framework. And this framework enforces a predefined workflow, so it guides the AI through very specific stages of solving the coding task. And what's interesting is that they found the smaller 7 billion parameter model actually showed more significant gains from self-improvement than the larger 32 billion parameter model.
That's a bit unexpected. You'd think the larger model, with all its extra capacity, would benefit more from that kind of structured guidance.
You would think that. But it seems that by simplifying the problem and offering clearer guidance, the specialized workflow kind of leveled the playing field. So the smaller model was able to catch up, and it displayed consistent performance improvements over multiple iterations of training.
So the specialized workflow acted as kind of an accelerator for the smaller model.
That's a good way to put it. And while the larger model started at a higher performance level, it only displayed very marginal improvements before plateauing.
Hmm. I wonder if maybe the structure limited its ability uh, to explore the problem space freely and maybe discover more innovative solutions.
It's possible. I mean, it's a really interesting question, right? How do we find the right balance between structure and freedom when we're training AI to code? It seems like the ideal approach might depend on the complexity of the task and the capabilities of the AI.
Yeah. And this is probably just scratching the surface. As AI and software engineering gets more advanced, figuring out that balance is going to be key.
Absolutely. It's going to be fascinating to see how this all unfolds.
Now let's shift gears a bit and
Mhm.
talk about this idea of AI judges, or what they call verifiers in this paper. They play a pretty crucial role in evaluating the quality of code that these AI coders generate.
Yeah, this is where it gets really interesting because now we're talking about AI, not just writing code, but actually understanding what makes code good.
It's almost like they're trying to teach AI to think like an experienced software engineer, right?
Right. They have the separate AI model that acts as a verifier, and it's trained to predict whether a piece of code is likely to pass the unit tests.
So it's like they're training an AI to have that intuition that a senior developer would have, where they can just look at code and know whether it's going to work or not.
Yeah. Spot those potential problems just by looking at it. It's pretty wild.
And how did having these AI judges impact the overall performance of the system?
Well, what they found is that it boosted the performance significantly. Because instead of just relying on a single solution from the AI coder, the system can now generate multiple solutions. And then the AI verifier picks the one that's most likely to be correct.
So it's like having a panel of experts reviewing different code solutions.
Yeah.
How did they actually train these AI judges?
They train them using the trajectories collected from SWE-Gym, both the successful and unsuccessful attempts. So the AI verifier learns not only what good code looks like, but also what mistakes to avoid.
That's smart. It's like learning from both positive and negative examples.
Exactly. And they found that training on a mixed data set like that led to the best results. And they experimented with training AI verifiers for both types of AI coding agents, the ones using general purpose prompting and those using the specialized workflows. And they found that both benefited from having that AI verifier involved.
So it seems like regardless of how the AI is actually generating the code, having that AI judge there to evaluate it is really helpful. But how significant were the improvements? Like how much better do the AI coders get with the help of the AI verifier?
Well, in one experiment, they found that using the AI verifier actually boosted the success rate on SWE-Bench Verified from about 20% to over 32%.
Wow, that's a pretty big jump. So it's not just making the AI coder a little bit better, it's like unlocking a whole new level of performance.
Yeah. And they also observed that the performance kept improving as they sampled more solutions and let the AI verifier pick the best one. So as those AI verifiers get more sophisticated and we can generate and evaluate more candidate solutions, there's a lot of potential for even further improvement.
It's kind of like in life, right?
Mhm.
Often having more choices leads to better outcomes,
Mm,
especially if you have a really good judge to help you pick the best one.
that's true.
Now, this research also included what are called ablation studies to try and figure out the most important factors for training effective AI verifiers. Can you talk a little bit about what those are and what they found?
Sure. Ablation studies are basically where you remove or alter different parts of a system to see what impacts performance the most. And one of the key takeaways was the importance of having a diverse data set for training the AI verifier. They found that combining successful and unsuccessful trajectories from both the AI coder and expert AI models actually produced the best results.
So it seems like understanding the full spectrum of possibilities,
Yeah.
both the correct and incorrect approaches, it's really important for developing a really robust AI verifier.
Yeah. And that makes a lot of sense. I mean, if you only ever see examples of perfect learned, you're never going to learn how to spot the mistakes.
Right, you need to understand what not to do as well as what to do. Did they find anything else that was really important for training those verifiers?
They also found that having a balanced data set with roughly equal numbers of positive and negative examples was really crucial because if the AI verifier is exposed to too many negative examples, it might become overly cautious and start rejecting even good solutions.
It's all about finding that right balance, right? To make sure that the AI verifier is discerning, but not overly critical. This whole concept of AI verifiers really raises a fascinating question, though. Like, what constitutes good code from an AI's perspective? Is it just about whether the code works correctly, or is there more to it than that?
Yeah. It's a great question, and honestly, it sparked a lot of debate. But from a practical standpoint, it seems like those AI verifiers are learning to identify code that not only works correctly, but also adheres to established coding conventions and best practices.
So they're learning to recognize those patterns in code that indicate not just functionality, but also things like readability, maintainability, and just overall elegance, qualities that we as human software engineers really value.
Exactly. And the connection to real-world coding tasks in SWE-Gym is really vital here because by training on data that reflects the actual practices of human developers, those AI verifiers are developing a more sophisticated understanding of what good code actually looks like in practice.
We talked earlier about how the AI coder's performance improves with more training data. Did they find a similar trend with those AI verifiers?
They did. They found that as they increased the number of training trajectories used to train the AI verifier, its ability to accurately identify those successful solutions also improved.
So more data equals better performance. It seems to be a recurring theme in the world of AI. Was there any kind of limit to how much data helps, though? Like, did they reach a point where adding more data didn't really make a difference?
That's a good question. And while having a sufficiently large and diverse data set is really important, there's probably a point of diminishing returns where adding more data just doesn't lead to significant improvements.
Right. At some point, the AI has learned the core principles, and additional data may not be providing much in the way of new insights.
Now, did they experiment with different ways of scaling the training data for those AI verifiers?
They did. They actually experimented with three main approaches. Random scaling, unique instance scaling, and repository scaling.
Okay, let's break those down a little bit. Starting with random scaling, what does that involve?
Well, random scaling is basically just increasing the total number of training trajectories, regardless of whether they're coming from the same or different coding tasks.
Okay, so you're just throwing more data at it and hoping for the best. Kind of, but the problem is that random scaling can actually introduce redundancy. So if the AI keeps seeing the same coding task solved over and over again, its learning might not be as effective as if it was exposed to a wider range of examples.
That makes sense. So how did they address that redundancy problem?
To try and address that, they explored what they called unique instance scaling. And this approach ensures that each coding task in the training data is represented only once. And what's interesting is that they found that this approach actually led to comparable performance improvements compared to random scaling, even though it resulted in a smaller overall data set.
So it's not just about the quantity of data, it's also about the quality and diversity of that data. Now, what about that third approach? Repository scaling. What was the idea behind that one?
Well, repository scaling is all about ensuring that the training data includes a balanced representation of coding tasks from different repositories.
So it's not just about the individual tasks themselves, but also the context in which those tasks exist.
Right, because different repositories often have different coding styles and conventions. And by exposing the AI to that variety, you can create more coherent learning signals, especially early in the training process. And it helps to mitigate the risk of the AI becoming too specialized in the conventions of just one particular repository.
So it's kind of like making sure that the AI gets a well-rounded education in coding, right? It's not just learning one specific dialect, it's learning how to speak the language of code more broadly.
That's a good way to put it.
Now, did the researchers express a preference for one of these scaling methods over the others? Or do they all have their own advantages and disadvantages?
Well, all those scaling approaches have their own merits and drawbacks, and the best choice is really going to depend on the specific goals of the training and the characteristics of the data being used. But one really clear takeaway from this research is that the diversity and representativeness of that training data are absolutely crucial for the success of both those AI coders and those AI verifiers.
It really highlights the importance of using high-quality data for training these systems. Because like that old saying goes, garbage in, garbage out, right?
Exactly.
Now let's dive a little deeper into how they specifically used SWE-Gym to train those AI verifiers, using those same two methods, general-purpose prompting and specialized workflows. Let's start with the general-purpose prompting approach. How did that work for training the AI verifier?
Okay, so for general purpose prompting, they took the AI coder's interaction history. That's the sequence of actions and observations it made within the SWE-Gym environment, and they fed that into the AI verifier as input.
So it's like giving the AI judge a detailed record of exactly how the AI coder went about tackling that problem.
Yeah, and because that AI verifier was trained on a massive data set of successful and unsuccessful coding attempts, it learns to associate patterns in this interaction history with the likelihood that the code will pass the unit tests.
So in a way, it's like the AI verifier is actually analyzing the thought process of the AI coder, right?
Mm.
It's looking for clues that indicate whether the AI coder took a logical and effective approach to solving the problem.
Yeah, exactly.
And then you mentioned earlier they use this metric called best at K to actually measure the improvement in the AI verifier's ability to select really high-quality code.
Mm.
So can you explain a little bit more about how that metric works?
Sure. So best at K basically involves sampling multiple solutions from that AI coder and then having the AI verifier select the best one out of, K candidates.
So the higher the K value, the more options that AI verifier has to actually evaluate.
Exactly. And what they found is that as that K value increased, the performance on SWE-Bench Verified also steadily improved. So basically, the AI verifier becomes more adept at identifying the truly best solution as it has more options to compare.
That's really interesting. So it's almost like having more choices coupled with a really skilled judge to help you evaluate those choices leads to better results.
Yeah, I mean, it makes sense, right?
Now, what about the specialized workflow approach for training the verifiers? How did that work?
Well, they observed similar results when they were training AI verifiers for AI coders that were using specialized workflows. The main difference here is that instead of giving the AI verifier the full interaction history of the AI coder, it was given a more concise representation of just the key elements involved in solving the task.
Oh, interesting. So it's like giving the AI judge a summary of a case rather than a full transcript of the trial.
Precisely.
And was that just as effective? Could the AI verifiers still make accurate assessments of the code quality, even with that more limited information?
It was. Despite that reduced output, those AI verifiers could still effectively identify high-quality solutions, leading to performance gains across all the different AI models they tested.
So it's pretty remarkable that even with less information, those AI verifiers can still do their job and make those accurate assessments of the code's quality. It really highlights the potential for AI not just to generate code, but also to critically evaluate it and help us improve our own coding skills.
It does. And speaking of which, this paper actually goes beyond just SWE-Gym. It also explores two additional data sets, SWE-Gym Raw and SWE-Gym Lite.
Oh, interesting.
Yeah.
Can you tell us a little bit about those data sets? What are they and how do they sort of fit into this whole research picture?
Sure. So SWE-Gym Raw is essentially like this massive collection of Python GitHub issues. It contains something like 66,894 instances across 358 different Python repositories.
Wow, that's a lot of data.
It is. And this really provides a valuable resource for researchers who are interested in training AI on real-world coding problems.
Yeah, it sounds like a treasure trove of raw coding challenges just waiting to be tackled by AI. What about SWE-Gym Lite? What's that all about?
Well, SWGym Lite is a smaller subset of that. It has about 230 instances, and these were specifically chosen because they're more, simple and self-contained. So they're ideal for researchers who are maybe just starting out with AI coding agents and want a more manageable data set to kind of experiment with.
Oh, that makes sense. So it's like a stepping stone. Researchers can kind of test out their ideas on a smaller scale before they move on to the massive SWE-Gym Raw or the full SWE-Gym environment.
Yeah, exactly.
Well, I think this research has really opened up some incredibly exciting new avenues for using AI in the world of software engineering. And it's going to be fascinating to see how these techniques evolve and what new applications emerge in the coming years.
I agree. It's a really exciting time to be working in this field.
Absolutely. Well, thank you so much for joining us on this deep dive. It's been a real pleasure talking to you today.
The pleasure was all mine.
And to all our listeners out there, thanks for tuning in. We'll see you next time for another deep dive into the world of AI.